No power. Imagine walking up to a computer, pressing the power button, and absolutely nothing happens. No lights blink, no fans spin, and there are no sounds at all. This is the no power symptom, and it is the most fundamental problem you will face when you troubleshoot motherboards, processors, and power. Think of it like a house that has completely lost electricity. Until you find the broken link in the chain, nothing else inside the house can function. When you're taking your CompTIA A+ exam, you must remember that a computer cannot do anything without a steady, reliable flow of electricity. Your primary goal is to trace the path of that electricity all the way from the wall outlet down to the internal microchips. To get your perfect score of 900, you have to be incredibly methodical and never assume the power supply unit inside the computer is dead right away. First, check the absolute basics of the power path. Is the power cable plugged firmly into the wall and into the back of the computer case? If the computer is plugged into a surge suppressor or an uninterruptible power supply, you must verify that those external devices are actually turned on, functioning, and have not been tripped by a recent power surge. Next, look at the back of the power supply unit itself. There is almost always a physical switch that toggles between on and off, represented by a 1 and a 0. Make sure it is flipped to the 1. Right next to that switch on older or cheaper power supplies, you might find a red voltage selector switch. This vital switch toggles the input voltage between 110 to 120 volts alternating current and 220 to 240 volts alternating current. Since you are living in the United States, this switch must always be set to the lower number, usually labeled as 115. If it is set incorrectly to the European standard, the computer will not turn on at all. Or worse, flipping it the wrong way while plugged in could permanently damage the power supply. If the external power path is perfectly fine, you must test the internal hardware using specific diagnostic tools like a multimeter or a dedicated power supply tester. You will need to open the computer case and carefully unplug the main 20+ 4-pin motherboard connector. Using your testing tool, you must verify that the power supply is correctly outputting the 3 distinct direct current voltages required by the system, which are 3.3 volts, 5 volts, and 12 volts. If the tester screen shows that any of these specific voltage rails are completely dead or providing electricity that is too low to run the components, the power supply is internally broken and must be replaced. But what if the power supply tests perfectly fine and all the voltages are correct? The next critical step in your troubleshooting methodology is to check the actual power button on the front of the computer case. That physical plastic button connects to the motherboard through tiny wires attached to the front panel header. Sometimes, the button itself mechanically breaks and cannot send the signal to wake up the power supply. A professional technician will unplug those tiny wires from the motherboard and use the metal tip of a screwdriver to briefly touch the 2 power switch pins together. This manually completes the electrical circuit. If the computer suddenly springs to life and turns on normally, you know the power supply and motherboard are perfectly fine, and you simply need to fix or replace the broken plastic button on the computer case. Finally, a no power symptom can actually be caused by a catastrophic short circuit on the motherboard itself. If a component on the motherboard, such as a capacitor, completely shorts out and melts, the power supply will immediately detect this massive electrical fault. To prevent a serious fire or further damage to the processor, the power supply will instantly trigger its internal overcurrent protection safety feature and completely refuse to turn on, leaving you with a totally dead system. In this advanced troubleshooting scenario, you would have to disconnect every single component and cable from the motherboard except for the main power, and slowly add them back one by one until the system refuses to start again. This process isolates the exact hardware piece causing the short circuit. Understanding this step-by-step flow of electricity will easily guide you to the correct answers on your exam.